Hi and welcome back. In this lecture I'm going to show you how to use a TIP22 Darlington transistor to drive an LED strip. You could use the same technique to drive other high current loads like motors, for example. So why do we need a TIP122? Well, we need it to drive large current loads. For example, this LED strip here or motors. Now focusing on the LED strip, a typical one requires 12 volts of operation. Just that is much higher than the 5 volts that the Arduino can provide. It can contain up to 600 LEDs in series, which could draw up to 2 or maybe sometimes even more amps of current at those 12 volts. So the Arduino can't provide this power. We need to use some external power, specifically for the LED strip, and then the Arduino to send out the instructions. So that happens via the TIP122 transistor in this example. A TIP122 is a Darlington transistor, as I said earlier. Darlington comes from the name of the inventor, Sidney Darlington, who back in 1953 invented this integrated circuit. In reality, inside the package, you have two transistors that work together. And the result of that cooperation is that we've got a device that can provide a much higher current gain as compared to our individual single transistor. If you apply a couple of volts at the base of this transistor, you'll be able to drive 2, maybe 4 amps of power through the collector and the emitter. So what I've got in this circuit is the Arduino, of course. I've got the TIP122 Darlington here, and I've got a power supply. This power supply is able to have a input that goes up to 30 volts, so whatever power supply external I have available that goes up to 30 volts, I can plug it in here, and then on the outside it's going to give me 12 volts plus 5 volts regulated voltage. So because I've got a LED strip, I want to be careful not to go too far above the 12 volts because I don't want to cause damage. Actually, I want to stay right on 12 volts. So that's why I'm not providing direct voltage, direct power from the wall power supplies to my LED strips. I want to have something in between to regulate that power. So that's where this comes in. Now, in the Darlington transistor, or any transistor, just think of it simply as a switch. You turn the transistor on, therefore you allow current to pass through it when the orange wire, which connects the pin 13 to the base of the transistor, so the base is this pin here on the left side, when that goes high, and high means anything above 2 volts for this particular transistor, then think of it as these two legs, these two pins becoming connected and closing a circuit. This is just a simple way of using a transistor. You can use it, of course, as an amplifier, but that's not what we're doing here. We are simply using it as a switch. So I've got the switching happening based on the pin number 13, or the state of pin number 13, and then the other two, the emitter. So the collector and the emitter pins are connected together, and that allows the LED strip to light up. One thing to remember is that unlike the 5mm LED, you can't just look at it and figure out which leg is, or which pin is short and which pin is long. So you don't really know what the cathode is and which one is the anode. It just comes like this, and you've got two wires sticking out. Of course they're colored, but sometimes that doesn't mean much. So to figure that out, what you can do is to plug your LED wires to your power supply, just like that, just directly. And if it lights up, then you know which one is anode. So this, well, let's see, I'll plug it in, actually. I'll plug it into my power. And let's see, I'm going to this is already plugged into, actually no, I'll disconnect it. Let's do this right. So I've got the red already on the plus side, and let's see if I plug this on the other side. Yeah, you can see that it lights up. So now I've got the black is the cathode and the red is the anode. Okay, so that's established. Okay, now I've got the schematic here, you can see it. So I'm going to plug the cathode in the base of the transistor. The anode, so the emitter of the transistor goes to the negative positive, sorry, the ground pin of the power supply. And I've got the program already running on the Arduino, so all it does is to make the LEDs blink randomly. Let's have a look at the sketch. There's not much in it. I just define the LED pin, then I set 2 variables that will hold the amount of time that the LEDs will stay on and off. And then I seed the random number generator just by taking a reading from analog port analog pin 0, which is not connected to anything, so its state is going to be completely random. And then the LED pin is 0. Now, inside the loop, I take a random number, or generate a random number between 50 and 500, do the same for round off, and then turn the LED on, wait for a random amount of time, turn it off, and wait for a random amount of time. And that's about it. So as you can see, it's very easy to drive fairly large loads using simple transistors, Darlington and PN transistors in this case. You could drive something else other than LEDs. It could be motors, for example, or other such loads. So I hope you find this useful. Any comments and questions, please feel free to ask.